All right, I got 11 o'clock Central Time, so I'm going to go ahead and start. Hello, everyone. My name is Andrew Wright. I'm the safety manager here at NAS Pensacola on the Hurricane Sally Package 6 project, and this is the monthly SSHO training for crane safety and oversight. Okay, so the learning objectives for this training are going to be to familiarize with the different crane types, the different components that are on cranes, and the applications that these cranes are used, and to bring awareness to crane-related hazards and the associated controls, to understand the crane inspection processes, to identify the roles and responsibilities for crane-related operations, and lastly, to review the SSHO oversight planning and oversight responsibilities. All right. So a brief history on cranes. Cranes have been around since ancient times. Early cranes date back to, ancient Greece around the 6th century, using pulleys, winches, wooden beams powered by people or animals to lift stones or for temples or whatever. Then they were developed further in the Middle Ages. Cranes were common in ports and construction sites, often mounted on towers or used in harbors and powered by tread wheels. It became more prevalent in the Industrial Revolution in the 18th and 19th century with the introduction of iron and steel and steam-powered cranes and to stronger, more mobile machines. And then today, there's wide aspects of cranes. Cranes use hydraulics, computer controls, and advanced materials, which enable precise lifts, heavy lifts in almost any terrain or structure type. Accident stats. So, fatal occupational injuries involving cranes. From 2011 to 2017, the census of fatal occupational injuries reported a total of 297 crane-related deaths, so an average of 42 per year over this 7-year period. Just over half of all fatal crane injuries involve the worker being struck by an object or equipment. About 3/5 of these cases involve the worker being struck by a falling object or equipment. And in 79 of these cases, the worker was struck by an object falling from or put into motion by a crane, so a release of a load or something like that. To dive a little bit deeper, the key causes of these incidents include 37% of workers being crushed by the loads, 27% due to dropped loads caused by rigging failure, 12% from falls from heights, including from cranes, and 11% due to workers being struck or run over by a crane. Many of these events stem from a lack of inspection, miscommunication, and untrained operators. This underscores the need for procedural enforcement and consistent training. And a causal factor was 90% of these were ultimately caused by human error and operator behavior, so which means they're 100% preventable. So some of these, accidents involving overturned cranes, drop load, electrocutions, boom collapse, and struck by incidents could all have been prevented. So this next section, we're going to go into the different types of cranes so you could familiarize yourselves with them. There's two basic overarching categories of cranes. You have your static cranes, these are your permanent cranes on your job sites, or your mobile cranes. These are the ones you can move around. They lift less, but they have the advantages of being mobile. So static cranes. These cranes are permanent or semi-permanent structures that remain in one location. The example shown in the picture is a tower crane. These are tall, fixed cranes with a vertical mast and a horizontal arm or jib used for lifting materials high up on skyscraper projects. There's also overhead crane. These are known as bridge cranes and typically found in factories or warehouses and run along a track or a bridge. And there's also gantry cranes. They're like overhead cranes, but they're supported by legs that run on a track. And they're often used to lift cargo from ships or in construction yards. And a side note on gantry cranes, they're pretty common in hangars. So if you guys have any jobs that are inside of airplane hangars, you might come across a gantry crane, and you should always lock them out if you're going to be working near them, because a unique hazard that they have is some of them have open electrical bus bars that power the cranes and go along the track, and if you touch those and they're not shielded, they could shock you. So you want to make sure that if you're working near them, they're locked out. So mobile crane types. These cranes are mounted on wheels or tracks, allowing them to be moved to different locations on the job site or between sites. Crawler cranes use broad tracks for mobility, making them ideal for soft or uneven construction terrain. Rough terrain cranes are designed for difficult ground conditions and have wheels for movement. All-terrain cranes offer the mobility of truck-mounted cranes and can travel at speeds on public highways. Truck-mounted cranes are mounted on a truck chassis, providing high mobility for transporting materials and equipment across the job sites. And telescopic cranes feature a boom made of sections that can extend or retract, and they're often mounted on a truck or other mobile base. And we'll get into those a little bit more in detail. So mobile cranes, hydraulic truck cranes versus a boom truck crane. These are very common on construction sites that need load handling equipment. So a hydraulic truck crane, this is a purpose-built heavy crane on truck carrier. It has a telescoping hydraulic boom with a high capacity and a long reach. Lifting capacity is typically between 30 to 600 plus tons. They have outriggers for stability, multiple axles for carrying the heavy load. They're used in construction, industrial, infrastructure, all sorts of stuff. Another common load handling equipment you'll see is the boom truck crane. These are commercial truck chassis with a mounted boom. They have a smaller telescoping boom, so it's a lower capacity and reach than the hydraulic ones. Their capacity is typically between 10 and 50 tons. They could travel highways easily, and they often double as a material delivery platform. You'll see them with a flatbed sometimes, and they could unload, material on your job sites or what have you. They're used for ladder construction, utility roofing, equipment delivery, those sort of things. Crawler cranes, as we talked about before, they offer the advantage of a 360 rotation, a high lifting capacity, versatile boom and jib configurations. Often they could self-assemble. They're usually a more expensive crane, so they're likely to have some advanced safety features, and we'll go into those safety features later on. Mobile cranes. Rough terrain crane is the one shown in the picture here. These have telescopic hydraulic booms, 4 large rubber tires for mobility on dirt, gravel, or uneven terrain. Typical lifting capacity between 10 and 150 tons. Outriggers are required for stability during these lifts. Advantages are usually 4-wheel drive with excellent maneuverability on rough job sites. They have a quick setup on uneven grounds, and they're versatile for construction, utilities, and industrial sites. Some of the limitations is lower road speed, so they're not typically highway friendly. Limited reach compared to a large truck crane, and they require a level setup for safe lifting. So you would use these on construction sites with poor or uneven access, utility and pipeline installations, industrial maintenance where terrain is rough. Last of the mobile crane section is floating cranes. So these are cranes that are mounted on barges, pontoons, or vessels. They're used in marine and heavy civil construction, on bridges, ports, or offshore work. Key features include a high lifting capacity, hundreds to thousands of tons sometimes. There's basically two types: not self-propelled, meaning that a barge just tows them, or self-propelled, meaning that they're ship-based. They operate in harbors, rivers, or offshore environments, oil rigs, or what have you. Require marine controls, mooring, ballasting, stability checks, all that. An advantage is they could handle extremely heavy loads, to build bridge sections, caissons, or offshore modules, and access to marine-only sites. All right, now that we've familiarized ourselves with the different types of cranes, let's get into some of the components and operational aids that are equipped on some to not all cranes. So crane components, the boom. In short, the boom is the long telescoping or lattice structure that provides the crane's reach and height. It's used to lift and move loads. The jib can either be fixed or luffing. And a jib is an extension attached to the boom tip to increase reach and flexibility, especially for placing loads at greater distance. The hook block or load block is a system of pulleys, and the hook that carries the load provides a mechanical advantage through reeving. Hoist line or wire rope. This is the heavy-duty wire wound on the hoist drum used to raise and lower the hook block and load. The hoist drum is a rotating drum that spools the hoist line to lift or lower loads. Sheaves. Sheaves are grooved wheels on the boom and block that guide and redirect the rope, which reduces friction. Counterweights are the heavy weights mounted on the crane's rear or superstructure to balance the crane and prevent tipping. Outriggers are the extendable supports or tracks that stabilize the crane during operation. The slew ring or swing bearing is a large bearing that allows the upper structure, superstructure, or housing to rotate 360 degrees on the carrier base. The operator cab is the enclosed station with controls, load charts, and monitoring system from which the crane is operated. The carrier or base is the lower portion of the crane that provides mobility, wheel or crawler mounted, and supports the superstructure. All right, crane operational aids. These are basically the safety functions that are present on some cranes. There's two different categories, Category 1 and Category 2 operational aids, and they have separate requirements for their operation and functionality. Depends on the crane and the application, but the load moment indicator, or LMI, is the electronic system that monitors load weight, boom length, and angle to warn if approaching an overload condition. The anti-two block device prevents the hook block from being hoisted into the boom tip sheave, which could damage the rope. So basically, it prevents the hook from being pulled up too far towards the tip of the crane to, prevent it from being damaged. The boom angle indicator shows the operator the current angle of the boom, and this is critical for load chart compliance. Boom length indicator displays the current extended length of the boom. These are often either painted on the actual boom itself, or they could be electronic. Rated capacity limiter prevents the crane from exceeding its rated lifting capacity by restricting functions when limits are reached. Level indicator, bubble level, or electronic, ensures the crane is set up level for safe lifting and accurate load chart use. Outrigger monitoring systems verify that the outriggers are properly extended and set before operation. Wind speed indicator, or anemometer, alerts the operator to unsafe wind conditions that could destabilize the load or the crane itself. Some other terms are the rated capacity. So you'll hear this term thrown around. It's unique for each crane, but it is the The maximum working load permitted by the manufacturer under specified working conditions. Such working conditions typically include a specific combination of factors such as equipment configuration, radii, boom length, and other parameters of use. Load charts. A load chart is a table or diagram unique to each crane model or other load handling equipment that details its safe working load, SWL, or its capacity for various configurations of boom length, angle, and operating radius. Crane dunnage. This is the supporting materials such as cribbing or outrigger pads used to provide a stable, firm foundation for mobile crane outriggers. Luffing versus slewing. So luffing is the vertical movement of a crane's boom or jib up or down, and slewing is the horizontal rotation of the crane's superstructure or boom. All right, next we are going to get into the specific hazards and crane related controls now that we're familiar with the crane types and the operational aids. So crane tip over or collapse. A crane collapse is probably the most catastrophic and potentially deadly accident that could occur on a crane. I'm sure you guys seen tons of pictures or seen it on the news when a crane collapses, especially in an urban area. It could be extremely catastrophic. So crane overturning due to overloading, uneven ground, or improper outrigger setup or high winds can cause it to tip over or collapse. Our controls and prevention are going to be always verify ground conditions and use crane mats or pads if necessary, for the outriggers. Follow manufacturer load charts, never exceed the rated capacity. So that's why we have to make sure that the load charts are in the cab and that we're following them and not exceeding them. Ensure the outriggers are fully extended and properly supported given the site conditions. And cease operations in high winds. Each crane is going to have its own, safe operating parameters for wind. So you should know that before you bring it onto the job site, so that if you're an SSHO and you observe abnormally high winds, you could pause the crane lift. And lastly is conduct pre-lift planning with a special emphasis on critical or heavy lifts, which a critical lift is anything that is over 75% of the rated crane capacity. Next hazard is contact with power lines. So crane boom, a load line, or a load coming into contact with a energized power line. Controls include maintaining a minimum approach distance. So for OSHA, it's 10 feet for up to 50 kilovolts. Greater distances are required for higher voltages. To confirm what the actual voltage is of the utilities in your area, you could request the utility company to identify the voltage. They could de-energize lines. They're unlikely to do that, but they may be able to provide blankets for the lines and insulate the lines if you cannot avoid coming within the approach distance, the minimum approach distance for that voltage. To avoid this, we use a dedicated spotter or a signal person to monitor clearance. Sometimes it's helpful to have a laser rangefinder, so you could tell exactly how far away a utility is from your load area, and you could barricade the area and know that the lift area and the boom radius will not come near the power lines if there are some in your area. You could also use warning devices, proximity alarms, or barricades. This slide just shows the minimum safe distances. So, the minimum is 10 feet from 0 to 50 kilovolts. That's on the bottom left. That's your standard, service power connections. And then you can see as the voltage increases, the minimum distance increases, to 15 to 20 to 25, 45, 35. And the huge over 1,000 kV is established by the owner of the utility and a engineer. So if you got anything with over 1,000 kilovolts, let's get some real professionals involved. Next slide is the hazard of falling loads or being struck by a falling load. So these are loads dropping due to rigging failure, improper securing or shifting, workers struck by swinging or falling objects. Controls and prevention is never allow personnel under suspended loads. Inspect slings, hooks, shackles, and hardware before use. Use taglines to control swinging loads. Train riggers in proper hitching and load balancing techniques. Exclude non-essential personnel from the lift area with barricades and signage. So typically, if you're going to set up a crane area, I always have a very healthy buffer zone around your area with plenty of warning signs and flagging just to keep people out of that area that are not vital to the lift operation. Next hazard is operator error and poor communication. This is an overarching causal factor in almost all crane-related incidents, but it's a miscommunication or lack of training leading to an unsafe crane operation. So controls are to ensure the operators are qualified and certified per OSHA and EM35 regulation. Use a qualified signal person for blind lifts or where the operator cannot maintain a line of sight with a signalman or where they can't see the load being dropped. Establish standard hand signals or a reliable radio communication between the operator and the ground people receiving the loads. Conduct a pre-lift meeting to review roles, signals, and lift plans. Verify the load capacities. And lastly, enforce a stop work authority. The policy is any worker can call a halt to an unsafe action. Next hazard is mechanical failure of cranes. So this is an equipment breakdown due to poor maintenance or undetected wear, such as a wire rope breaking, a hydraulic failure, or a boom collapse. Controls and preventions. Perform your daily operator inspections and your periodic third-party inspections, and we'll get into inspections a little bit later. But follow the manufacturer's recommended maintenance schedules. Replace worn or damaged wire ropes, sheaves, and hydraulic components, and document all inspections and repairs. Environmental factors. So as you can see on the right, it's a real picture of a lightning bolt hitting a crane. Boom. That was probably very scary for everyone over there. Weather conditions such as wind, lightning, heavy rain, snow, ice, or fog can create unsafe lifting conditions. So controls are to suspend operations during lightning, severe storms, or poor visibility. De-ice or clear snow from crane components before use because the ice or snow will add restrictive movement. It'll add weight, to the crane, and it'll make the hydraulic fluid, thicken up. Monitor wind speeds at boom heights, not just on ground level. So most cranes have a wind speed indicator on the top of the boom where it's at its height, so you'll know exactly how high the winds are at the top of the load. Provide for adequate lighting for night operations. Know the limitations of the equipment, i.e. what is the max wind speed operation for that specific equipment. Saturated grounds may make outriggers unstable, so you want to inspect the grounds after any rain event and make sure that everything is still stable. Next hazard comes from the assembly and disassembly process. So a lot of crawler cranes and tower cranes have to be assembled on site. So that's prevents a unique set of hazards that are different than when you're just basically lifting the load to and from. So these are workers exposed to falls, crushing, or structural instability during crane erection and dismantling. Controls are to follow the manufacturer's procedures and engineer plans for assembly and disassembly. And typically you're going to have one person, a go-to guy who's like your assembly or your disassembly director. He's the person who's going to take overall responsibility for ensuring that crane is assembled and disassembled safely. So that's why we use only trained and qualified personnel. We have to implement fall protection wherever it's required and feasible. And we have to exclude non-essential workers from the assembly and disassembly zone. And lastly, we need to conduct a pre-task hazard analysis before we start any assembly or disassembly procedures. Next hazard is it's falls from heights. This can be, during any aspect of crane use. So the general requirement, as everyone knows, fall protection at greater than or equal to 6 feet, according to OSHA 1926-501 and EM 35, Section 21. So when some workers may be exposed to fall hazards during a crane operator access to the cab, so we need to provide them safe access ladders, walkways, or platforms are required. No climbing of structural members without personal fall arrest systems. So assembly and disassembly. Fall protection under OSHA. Fall protection is required unless the employer shows that it is infeasible, or it creates a greater hazard. Under EM 385 jobs, fall protection is always required, including during assembly and disassembly, unless, again, it is unfeasible, but you have to have documented hazard analysis and approval to do that work without fall protection. Basically, have to make a case of why fall protection is either not going to work or it's going to create a greater hazard. Boom, tower, or jib work, personal fall arrest, full body harness, lanyard, SRL, when climbing, erecting, dismantling, or working outside the cab. And as a reminder, anchor points must meet the 5,000 pound or engineered equivalent. All right, this next section involves crane inspections. We're going to go over a couple different forms of inspections and what the OSHA requirements are and what the EM 385 requirements are. A lot of the information on the OSHA and the EM 385 requirements are similar, but there are some different caveats for each of those entities. All right. Pre-shift crane inspections per OSHA. So this is in the 1926 1412 subsection D. These are your daily pre-shift inspections. They include a functional and operational check. So you're going to be checking things like, or not you, the operator will be checking things like controls for proper operations, levers, switches, test the buttons, checking the safety devices and operational aids like the anti-tube lock, the boom angle indicator, the load moment indicator if it's equipped, any other operational aids that are equipped, make sure that they're working properly, and your emergency stop switches. Your safety devices must be in proper working order. Again, this is your tube lock device, your hoist limiting device, your luffing jib limiting device, load moment indicator, outer regulator, and stabilizer sensors. You're going to want to take a look at the rope, or the wire cable, visual inspection for damage, wear kinks, bird caging, broken wires, and lubrication. The operator will take a look at the hydraulic and pneumatic systems, pneumatic meaning air, hydraulic main with hydraulic fluid. You're going to look for leaks in lines, tanks, valves, drain pumps, anything like that. Make sure the fluid levels are adequate. They're going to take a look at the ground conditions, make sure nothing has changed since the last time it's been set up. Check the outriggers, the mats, the blocking, the ground stability. Inspect the hook and the latch for deformation, cracks, proper latch operation. Check the hoist, boom, and jib components for cracks, deformations, wear, or missing bolts, pins, or other hardware. And tires, if it's equipped, make sure that they're inflated and in good condition. And lastly, if there's any deficiencies, you need to document them. So pre-shift inspection per EM 385, it mirrors a lot of the items for the OSHA's inspections. There's a pre-standard lift checklist that is required on U.S. Army Corps jobs that are governed by the EM 385. That's the Form 16-2 standard pre-lift checklist that should be completed daily by the operator. Some inspection items, I'm not going to go over them all again, but some unique ones to the EM 385 is you got to make sure the load charts are present, legible, and applicable to the configuration. They want you to inspect the fire extinguisher, that it's mounted and inspected, for its monthly service and its annual service as well. Make sure the horn and audible warning devices are tested. Make sure the wind speed indicator is working. Make sure the backup alarms and the lights are checked. Check the swing brake, the boom brake, and travel alarms. That's what stops the load when it's coming down, being lowered. Wire rope inspected per ANSI, ASME criteria, and any questionable conditions require review by a qualified person. Record keeping, unlike OSHA, EM 385 explicitly requires written documentation of pre-shift inspections retained for the life of the project. Documentation must be made available to the Government Designated Authority, or GDA, upon request. Corrective actions. If there's deficiencies noted, the crane must be removed from service immediately until a QP verifies its safe operation, and all repairs must be documented. So that was pre-shift inspections. Now these are monthly inspections. They're completed by a competent person. They need to be at least once a month. Every month the crane is in use per OSHA. So same items as a daily shift inspection, your control mechanism, safety devices, wire ropes, hooks, latches, pneumatic systems, hydraulic systems, tires, tracks, ground conditions, boom, all that. A documentation is required, so you have to have a written record of this inspection and keep on file for at least 3 months. You must identify the crane, the inspector, the date, deficiencies, and corrective actions. Any unsafe conditions will result in the removal of the crane from service until it is corrected. Annual crane inspections are required for all cranes. So it's all the shift inspection items plus equipment structures, including the booms and the jibs, the structural members for deformities or cracks, loose or broken bolts, rivets, or other fasteners, welds for cracks or deformations. Check the sheaves and drums for cracks or wear. The inspector will check pin bearings, shafts, gears, rollers, and other locking devices. We'll check the brakes and clutch systems, any safety devices and access safety. They're going to go over the power plant, usually a diesel motor, pressurized hoses and fittings, hydraulic and pneumatic pumps and motors, and they're going to make sure all the warning labels and decals are legible. All right, this next section, we're going to go over the different roles and responsibilities for people involved with crane operations. All right, so the controlling entity. The controlling entity is essentially the prime contractor or GC or any other legal entity that holds overall responsibility for the project's planning, quality, and completion. So on our job sites, most of the time ECC being the prime contractor, or GC is the controlling entity. So we have overall responsibility for that crane operation. And so OSHA requires, the controlling entity to ensure that adequate ground conditions are provided for a crane setup, that it's firm, it's drained, it's graded, and has supporting materials. Basically, the controlling entity is required to provide a safe working environment for the crane to set up on. It's not the responsibility of the crane operator to go and prepare your job site for a crane to be set up on it. So they also need to coordinate crane operations when multiple employers are on job sites. So that's basically deconflicting other trades or other people or other contractors working within your lift area. Share information with the crane user about known site hazards. If there's utilities or underground hazards, traffic hazards, other trades. That's why it's really important for the SSHOs to get out there and really do a thorough inspection of the grounds. Sometimes you'll set up a crane and there'll be storm drains, or there could be, tanks stored underground. You could always reference, as-built or reference drawings to see if there's any, potential for anything underground that you don't see. And you could always look at the building exterior if you're near one for evidence of, anything underground. You could look for, gas service lines or water service lines, and you could also have the area located, if you want to be extra cautious, to find anything that is a subsurface anomaly. EM385, the GC is responsible for ensuring safe crane operations on the site overall. They must review, approve lift plans and critical lift plans, and verify government acceptance when required. So that's part of our submittal processes. Ensure access roads, swing radius areas, and lift zones are controlled and secured, and designate who will serve as the lift director and verify their qualifications. Next is the crane operator. So per OSHA 1926, 1427, they must be certified by a nationally accredited certification body, e.g. the NCCCO. Perform pre-shift inspections and ensure deficiencies are reported and addressed. Operate the crane per manufacturer's instructions and the load charts. Stop operations if unsafe conditions exist. So, high winds, loss of visibility, mechanical failure. Ensure no lift occurs without a signal person if it's required, and make sure that they are sober and are paying attention. EM385, again, it's just going to be that the operators must be qualified and certified with documentation available on site. They need to verify that the safety devices or operational aids are functioning. They need to participate in a lift plan execution, including trial lifts for personnel platforms or critical lifts. And they have stop work authority along with everybody else. So ultimately, if the crane operator isn't on board, you need to listen to them because they are the subject matter expert and are responsible when that crane is being operated. So here's an example of a crane operator certificate. So you can see this handsome young gentleman, Joseph Andrew Operator, this crane card. So OSHA requirements, operator certification since November 2018 requires all crane operators on construction sites to be certified by an accredited testing organization like the NCCCO or NCCER, CIC, or OECP. Don't ask me what all those acronyms mean. I don't know. Applies to most cranes above 2,000 pound capacity. So employer duties, employers must evaluate operators to ensure they can safely operate the equipment that they are assigned. The evaluation must be documented and available upon request and submitted for our approval and the government's approval. Certification alone is not enough. It requires employee verification as well. Some exemptions, certain equipment like digger derricks for electric utility work, tow trucks, and other service trucks are exempt from these crane operator certification requirements. The next role is the lift director, or sometimes referred to as a lift supervisor. This is a trained professional who is responsible for overseeing all aspects of a lifting operation on site to ensure safety, efficiency, and compliance with the regulations. They're going to be involved with the pre-lift planning. They're going to review and sign the lift plan, standard or critical plan, verify operator, rigger, and signal person qualifications, briefing and communication. They're going to conduct pre-lift meetings, toolbox talk meetings when the crane is on site and being used, establish a signal communication method, site and load control. They're going to confirm ground conditions, the exclusion zones, the barricades, verify the load weight, the rigging, and the capacity compliance, ensure devices and operational aids are functional. During the lift, they're going to direct and oversee the entire operation. They're going to stop the work if unsafe conditions develop, and they're going to coordinate with the operator, riggers, and SSHO. And in certain conditions, you could have the operator also be the lift director. It kind of depends on what you're doing. Next is a qualified rigger. This is a person with specific training, knowledge, and experience to select and inspect rigging equipment, attach loads to a crane, and guide the load safely while maintaining load stability. So under OSHA, it's required when workers are within the fall zone during hoisting activities. They must be qualified by knowledge, training, and experience to rig safely. They need to know how to select the proper rigging gear and inspect it before use and know when to red tag it. They need to ensure slings, shackles, chains, and other hardware are rated for the application, protected, and rigged correctly. And they are responsible for attaching and detaching the load safely and for using tag lines. Under EM 385, they need to be qualified and trained as well and must be documented, and it should be part of your lift plan submittal along with the crane operator certs. You need to ensure load stability, center of gravity, and proper use of tag lines. I need to report defective rigging equipment to the SSHO and red tag it. And on a side note, all rigging that is used for lifting should have a legible tag. As you can see in the picture, there's the orange tags on there. If you have a strap, shackle, cable, whatever that is going to be used for lifting and does not have a tag, or the tag is missing, you cannot use that rigging. Signal person. This is a person who is knowledgeable about types of signals used, can competently use them, and understands crane operations and limitations, and can prove these abilities. They are designated in writing, qualified by a third-party evaluator, and can use radio, cell, or hand communications. So as you can see, all the different hand signals being used, and a signal person is especially going to be required if the operator cannot see where the load is being dropped, so it's a blind lift, or if they're if the operator cannot be within line of sight of the signal person, you have to have an alternate means. So whether it's a cell phone or radio communication, sometimes it can be hard to get radio communications approved on sites that are near air traffic controls. That's something you should think about. So that's when signal persons are required. And ultimately, like if the operator ever loses sight and doesn't know where the signal person is or anybody else, he should pause and stop until he can verify that that person is out of potentially harm's way. All right, this next section is the lift planning and SSHO oversight responsibilities. This is where we as safety professionals come in with our safety knowledge to oversee these crane operations to ensure that they are executed safely and according to plan. So SSHO oversight responsibilities. As an SSHO, our job is not to operate the equipment, but to ensure that the task is planned accordingly and safe operational procedures are being followed. So examples are ensuring that crane activities are pre-planned, um, confirming that the lift plan is approved by the government, and sometimes assisting with putting the lift plans together. Typically you want to have the crane company provide you with the lift plan, but sometimes they need a little bit of work because they're not used to providing what the government is asking for as far as lift plans. So you could assist them with collecting all the data and all the submittals that they need as far as like certifications and the specs of the load that you're being lifted and that you're lifting and the type of rigging being used. You also want to verify the crane setup areas, the swing radius, and the travel paths are identified and controlled. You need to verify the qualifications and certs of the crane and support personnel. So that's the operator, the rigger, and the signalman certifications. You need to make sure that the crane inspection checks are being conducted. Ground conditions, ensure that the controlling contractor provides adequate ground conditions and that the outriggers are firmly set. Do a little visual inspection of your job site every day, especially after inclement weather, to make sure nothing has changed. Also, if you're on a military base, especially if you're working near barracks or something, make sure that nobody has messed with your equipment or move things around or mess with stuff. We've had that happen before on our job sites. Also, make sure that they take the keys out of the cranes and other equipment like that at the end of the day, so it doesn't get used without permission. Load charts and capacity verifications. So make sure the operators have a load chart in their cab or an access to it. Make sure there. On a side note, there should also be the crane instruction manual present with the equipment. And every now and then you're going to want to do a spot check and ensure that the loads do not exceed the rated capacities. If you are under the understanding that they're going to be lifting single sections of say structural steel members, and now all of a sudden they're lifting multiple ones, that should maybe raise a red flag, especially if they have been planned for doing tandem lifts or multiple lifts. You should throw up the red flag and ask a question at least. So SSHO oversight responsibilities continued. Rigging checks, ultimately the qualified rigger is going to be responsible for this, and that's going to be associated with the crane company hired. But you could make sure you can keep them honest and do spot checks yourself. You could check the slings, shackles, and hardware. Make sure it's inspected, that they're filling out inspection forms and inspections are documented. Maybe do a little once over. Nylon lifting straps and slings are notorious for getting cuts and abrasions on them, or just being damaged by the sun, or missing the appropriate tags on them. So you could check that. You could make sure that the tag lines are being used for controlling the loads. You want to make sure that if there's power lines in the area, that they are staying well within the safe approach distance given the voltage. You need to make sure that the operator has fall protection and safe access to the crane cab. You need to make sure that they're doing their operational checks on their operational aids. So that's the anti-two block devices, boom wiggle indicators, load weight indicators, and radius indicators must be functional. And lastly, this is a very common responsibility for us on the job sites, because a lot of times the guys involved in the lifts, the operators and the signalmen and the riggers, they're not watching the weather or the skies. They're focusing on the lift. This is where we can come in and assist them. So if we see that there's high winds or lightning approaching, we need to pause and shut down the operation. You should also check with the crane manufacturer specs and make sure that the wind speed restrictions are being followed, because sometimes they'll push it. They'll they'll want to, they're getting paid and they want to get the job done, so they'll sometimes push it. And you could use, mobile applications for tracking lightning. I use one called My Lightning Tracker. It allows you to set up a radius of your job site and it will notify you if there's a lightning strike within that radius. So I put mine at like 15 miles. So at least I have some time, because you're supposed to stop all outdoor activities if you have lightning encroaching within 10 miles on government sites. So that just gives you a little bit of buffer time to, stop the operation, get the load down safely, and get everybody to shelter if needed. So lift plans, we talked about this a little bit, but if you're required to submit a lift plan, you may need to verify basic information and submit it to the GDA for approval. So again, you want to verify the crane type and model. This isn't saying that you need to, suggest the type, model, and weight rating. That's going to be done by the professionals, but you could at least get the model number and specifications, from the crane operation company, so that you could verify that it's being used in the manner that it's intended. You could verify the loads, ensure the load handling equipment and associated rigging submitted can safely handle the load. Do a spot check, make sure that, if you got a 10,000 pound load that is going to be 10,000 pounds and they submitted rigging that is only rated for 2,000 pounds, that should be your red flag and you should get that corrected. You want to make sure to include the load and all associated rigging when calculating the total load. So if you need to calculate the load, don't just calculate the load itself. You need to incorporate the weight of the rigging as well. The load chart should be referenced. So you should approximately know like where the boom and angle extensions and the corresponding weight reductions are going to be shown in the load chart. So for instance, like if the boom is going to be completely extended out and at a 40 or 60 degree angle, that's going to correspond to a certain area on the load chart, and that will correspond to a weight reduction, because as you know, the higher and the further out you get away from the crane's center of mass, the less you could lift. So it's the same with any load handling equipment, like a forklift or anything like that. The further that boom goes out, the less it could weigh, the less it could pick up. So just because you maybe have like a 10,000 pound rated piece of equipment, if it's extended fully out horizontally, it could be down to 1,000 pounds or 2,000 pounds. So that's where being familiar with the load charts will aid you in, preventing accidents. And lastly, you want to make sure the crane and rigging credentials are up to par. They do have expiration dates on some of these certs, so make sure that they're not expired, and make sure that the guy who shows up is the one that was submitted. All right. Oversight intervention examples. So, there may come a time, sometimes a pause in operations may be, necessary for safety reasons. And, you may be hesitant to stop work, but, in the end, as an SSHO, you are obligated, if you feel like there's an unsafe action or condition present, to stop work, or at least pause work and ask questions if you're unsure. So some examples of times where you may want to pause or stop work is, after a rain event, you recognize some soft ground conditions, and maybe, the ground is going to be a little bit unstable and can create the potential of a crane tip over, which would be catastrophic. So you want to make sure that if you see something like that, you say something. Weather conditions, as we spoke to earlier, you're out there on the job site, make sure you're looking at your weather conditions and your weather forecast for the day. Look at the radar. If you see like you got some storms coming in, make sure the crew is notified well in advance, and definitely pause work when you hear thunder or anything like that. Load chart is missing or damaged. Some of these crane equipments, they get used heavily, and the company may not think it's important for the load chart to be there because maybe the crane operator's got 20 years experience. He doesn't need a load chart, but it's required to have one on there. And if something happens, there's an accident and that's not on there, that's something that's going to be held against you. Next, if you see someone who is encroaching in your barricaded zone, whether it's a member of the public or a supervisor or anybody who is going into the lift zone or the swing radius or underneath a suspended load, that needs to be a pause in operation to get those people out of there. Keep the people involved in the lift area to a minimum. And that includes yourself. If you don't need to be in the harm's way, observe from a safe distance. Another thing to stop work, if you see the crane operator, he's not attentive, he's on his phone or sleeping or whatever, pause operation until he's on the controls and paying attention. Another example would be if the rigging doesn't match the lift plan or is damaged, or the load doesn't match the lift plan, that's where we go to the making sure that the lift is planned out accordingly. Or if they do a bait and switch on the operator, which I've seen where they submit one person as an operator and then somebody else completely different that you haven't vetted shows up to work. So in that situation, you want to pause until you can verify that the actual people who are operating the crane are trained, qualified, and certified, and approved. And lastly, if you observe an unsafe crane operation, like side loading or pulling or dragging a load, that can't happen. You need to stop that. All right. In summary, that sums up our SSHO oversight for crane safety presentation. At the end of the day, safe crane operations, depends on, qualified personnel, proper planning, strong SSHO oversight, and, just a team mentality. So if you see something unsafe, say something. It doesn't hurt to take a pause on an operation to ask a question. So that's it. If anybody has any questions or anything like that, I'd be happy to attempt to answer them. I didn't see if there's any questions in the chat because I don't have that window open. But if not, thank you. Appreciate it.
Thanks, Andrew. Awesome job.
Thank you.
There's a link in the chat for everybody to go on and fill out your attendance survey. It'll be a quiz on the information Andrew just went over. That'll just capture your attendance for today.